strict, and we have to quickly pass through the final presenter, Marta Picciolini. Where is Marta? Okay. Good morning, Marta. And I have your presentation, and I can post directly your presentation. Okay.
Does noise matter? Man-made noise changed the acoustic underwater soundscape. It is now considered a pollutant of international.
Stop. I have to share the screen. Excuse me. Not a stop, please. Okay.
Does noise matter? Man-made noise changed the acoustic underwater soundscape. It is now considered a pollutant of international concern, given its potential to harm marine species at the physiological, behavioral, and communication levels, leading to the potential consequences in terms of survival and fitness. In the MED, in situ evaluation of both noise impact has been mostly run in MPAs, showing short-term behavioral change in fish swimming, feeding, reproductive, and territorial activities. But do fish avoid high noise areas? And how to monitor fish in areas characterized by high boating and shipping activities? The passive acoustic method is the best option for studying the species-specific distribution of vocal animals. This is of particular interest if we consider that 7 out of 10 fish species listed in the treated categories by UCN in the MED are vocal. This is also the case of China umbra and Umbrina cirrhosa, two cyanid that are recognized as treated by the UCN due to overfishing. The feature of their vocalization have been described in details and show to be consistent in space and time. This study focused on the distribution of China umbra in the Venice Inlet. Venice is located in the northern Adriatic Sea. It is one of the largest lagoons in Europe. Its port is a passenger port in the lagoon city and a commercial port on the mainland. 3 inlets connect the Venice lagoon with the sea. They are made by long rocky piers that extend far offshore. They represent artificial hard substrate with holes and shelters close to the soft bottom that characterize the area. All the vessel traffic to and from the lagoon pass along the inlets. Since 2003, the inlets have been part of a construction of the experimental electromechanical module, a system of mobile barriers built to limit flooding of the historical city of Venice. This has been contributed to the substantial modification of the inlet's morphology. The presence of Siena umbra along the inlets was early inferred by means of its vocalization. Siena umbra is indicative of a good environmental quality. It is an umbrella species for the ecological community of the rocky coastal habitats, and is listed in the Annex C of the Barcelona Convention. Siena umbra emits drumming sound during the reproductive period. These sounds are made by 1 to 11 pulses within a frequency range between 50 and 2000 Hz. 3 patterns of sounds have been recognized. See the irregular pattern, lacking any fixed repetition rate. The regular rhythm, made by stereotype sounds, highly regular in sound interval, and the chorus. Siena umbra sounds can be also quantitatively analyzed by scoring the number of pulses per minute, here defined as the pulse rate. The pulse rate can be further scaled on an arbitrary quantitative scale, which is called the pulse code. This allows the classification of the recording points according to the acoustic density that is indicative of the biological importance of the area for Siena umbra. This research aimed at evaluating the vessel traffic and the background noise along the Venice inlets, and to monitor the spatial distribution of Siena umbra by its acoustical activity. and interpreting the fish distribution in relation to the local underwater anthropogenic pressure. 3 surveys in June, July and August have been run per 2 years at 40 listening points located internally and externally in the inlets. The recording points were located along the Lido Inlet, the Malamocco Inlet and the Chioggia Inlet. Each listening point was replicated twice per station. 5 minutes acoustic sample was collected in the late afternoon corresponding to the local peaks of boat traffic, and the second 5-minute acoustic sample was collected a few hours later corresponding to the peak of the species' vocal activity. The hydrophone was lowered from an open boat to an average depth of 4 meters. Sampling was carried out with a sea state of less than 2, and a log of the vessel visible by eye per each acoustic recording was obtained. Data was analyzed in terms of SPLs and 1/3 octave band SPLs, and manual scrolling of the spectrograms allows to calculate the Sciena Umbra pulse rate and code. What about anthropogenic pressure? We estimated about 30 vessel passengers per hour in the afternoon recordings and about 10 vessel passengers per hour in the night recordings, with SPLs in the wideband ranging from 107 to 137 dB Re 1 micropascal. SPLs were highly influenced by the number of vessel passengers in the acoustic sample. We calculated energy level for the frequency corresponding to the species' best hearing range. We obtain an average difference between the Sciena Umbra audiogram and the median energy level equal to 10 dB Re 1 micropascal for the afternoon and night recordings, 17 dB Re 1 micropascal for the afternoon recordings containing more than 3 vessel passengers, and 40 dB Re 1 micropascal for the night recordings presenting Sciena Umbra chorus. This is relevant because Sciena Umbra is a sedentary species and the afternoon noise pressure is experienced by an animal vocally detected in the night. Sciena Umbra low-frequency sounds are clearly detectable even in the presence of vessel noise. This allows to create a spatial map of the Sciena Umbra distribution in the inlets. With different colors we highlighted different vocal rhythms. Like black dots indicate the chorus, the dark gray dots the regular pattern, with light gray dots the irregular pattern, and white dots indicate no sounds at all. The chorus occurs consistently in localized areas throughout the breeding season. This is important because the chorus is a proxy for spawning events in other cyanids. In captivity, in particular, longer sounds with a higher number of faster repeated pulses are associated with cyanid spawning events. This was also the case of the Sciena Umbra vocal recordings in the inlets. In the regular pattern and pulse code number 3, we have on average 5 pulses per sound, whereas during the chorus we arrive up to 7 pulses on average per sound. So at sea, during the chorus, a higher number of faster repeated pulses was found in the species. This leads us to conclude that in the Venice Inlet, Sciena Umbra spawning is not a spatially diffuse event, but it's concentrated in preferred location, and there is a spawning site selection. We also grouped the listening point on the basis of the vocal activities of Sciena Umbra that is quantitatively scored by using the pulse code. Highest vocalization rate as the group 1 is located only in the busiest internal side of the Malamocco and Lido. Energy levels and vessel passengers were definitely higher in the location with higher pulse code. So we conclude that brown meager does reproduce in this site despite the relatively high anthropogenic noise levels experienced mostly but not exclusively during the diurnal hours. Also, the she-drum Umbrina cirrhosa reproductive vocalization were recorded in the internal side of the Malamocco inlets. As Sciena Umbra, also Umbrina cirrhosa is defined as treated by the UCN, and they are closely related species characterized by a partially overlapping ecological niche. We discriminate their presence according to their vocalization as described in captivity. serosa reproductive sounds were made up of a lower number of longer pulses with a different envelope repeated at a lower rate than those of Siena umbra. We conclude that the Venice inlets are relevant location for the reproductive of this cyanid species. But which factors explain Siena umbra spawning site selection observed in Venice inlet of this cyanid species? But which factors explain Siena umbra spawning site selection observed in Venice inlets? We consider hydrodynamic factors as water current and tide level, structural factors as bathymetry, slope, roughness, and position in the inlets, temporal factors as the campaign, the water temperature, the recording time, and anthropogenic pressure factors as the noise levels and the boat abundance. Binomial generalized linear models were used to evaluate which predictors best explain the occurrence of Siena umbra chorus, which was here considered as the response variable. And although this is still in progress study, we observed that hydrodynamic, structural, and temporal factors were relevant in this context, whereas the anthropogenic pressure factor were not. So, concluding, Siena umbra has been identified in the traffic Venice inlets due to the species-specific sound feature, and all the previously described vocal patterns have been recorded. The chorus is strongly related to spawning, and the areas with a repeatedly recorded chorusing activity are the spawning of the species in the inlets. Spawning is concentrated in the internal side of the Malamocco and Lido inlets. Spawning sites are characterized by higher anthropogenic pressure compared to other listening points. Therefore, the spawning site selection seems to be not influenced by the local background noise level. Spawning site selection may be rather connected to the physical and structural inlet characteristics, and this is what we can call the rocky habitat effect, because the inlets resemble the rocky habitat that are typical for the species. Overall, we want to stress that the behavioral response does not solve in a linear relation like cause-effect, but depends from the cost-benefit balance associated with alternatives. A species, as this was the case, may remain in disturbed site according to its resource distribution, like reproductive sites or feeding, adopting a conditional behavioral strategies to cope with it. Thank you for your attention.
Okay. Marta, do you believe that it has been correct, the presentation, or there has been some jam? I am not sure.
Everything is fine. And thank you so much for your help, and thank you for the conference itself.
It's so difficult to manage these things.
Yeah, I'm sorry about that.
It's not my work. I'm not a art director. Good. Well, we have there are some questions from the audience.
Okay.
Please.
What do you think about the long-term effect of noise on population? And thanks to Giusy for this question. I think this is a really important question. And actually, the study has been also run with an eye on the effect of these mobile barriers that could close the inlets for the traffic. I mean, they will stop the water, but they will stop also the boat to coming in and outside the inlets. On the other side, they will stop also the currents and the flow. And so all these parameters we considered will be changed according to what will go on with these mobile barriers. So actually, we are looking for long-term effect. We don't know right now, of course, and this is one of the goals of the project. And thank you, very interesting talk. Is there any change that did not contribute to the species use sound for short distance communication? Yes, of course, this is a point we raise when we discuss our data. This is true mainly because as you see in the presentation, Siena Umbra and also Umbrina Cirrosa produce sounds during the evening or before midnight, let's say, but not during the day, whereas the peak of the traffic for both presence is around midday and late in the afternoon, but not after sunset. However, there are different thoughts about this. One is that we also have in literature some researches that have been done in Sardinia, in the MPA, the Capocaccia, that show that the animals increase their hiding behavior in presence of both. And on the other side, in Miramar MPA, a paper of many years ago show that the animals try to cope with noise doing a sort of vocal compensation, increasing their sounds actually. So I think the aspect about the communication between animals, it's quite wide. It takes many consideration into it. And could you say what that the recording were made? Yeah, we recorded the sound from a boat with a spatial mapping because of the relatively short duration of the vocalizing peak for the species in order to move from one place to other one. And we lower the hydrophone at a depth of about 4 or 5 meters in the shallow water and a couple of meters more and something more when we have in the internal part the shallow, the deep channel. Thank you for the questions.
Okay, thank you, Marta. Thank you very much. And now it's the time for the work